Hello everyone, let's continue stereochemistry. In our previous video, we discussed about the symmetry elements. Now let us try to understand in what way symmetry elements will help in determining whether a compound is optically active or not. So basically, what is an optical activity? So optical activity is the ability of a solution of a chiral compound to rotate the plane of plane polarized light. So what do you mean by plane polarized light? So ordinary light will vibrate in all the directions. When that ordinary light is passed through the prism or a grating, so you will have a light that will vibrate in only one plane. That light, when passed through a solution of an optically active compound, the plane of that plane polarized light will be rotated either towards left or towards right. If the compound rotates the plane of plane polarized light towards right, then it is called as dextro-rotatory compound and designated with small d or plus. However, if it rotates the plane of plane polarized light towards left, it is called levo-rotatory compound and designated with small l or minus. ఒక ధ్రువణ భ్రమణత కలిగినటువంటి సమ్మేళనాన్ని పొలారిమీటర్లో ఉంచినప్పుడు, దాని ద్రావణాన్ని పొలారిమీటర్లో ఉంచినప్పుడు సమతల ధ్రువిత కాంతి తలాన్ని కుడివైపు కానీ ఎడమవైపు కానీ భ్రమణం చెందిస్తుంది. కుడివైపు భ్రమణం చెందిస్తే దాన్ని డెక్స్ట్రో భ్రమణ సమ్మేళనంగా, ఎడమవైపు అయితే లివో రొటేటరీ సమ్మేళనంగా దాన్ని గుర్తించడం జరుగుతుంది. So now, is it always necessary to use a polarimeter to determine whether a compound is optically active or not? If it is optically active, it is called chiral compound. If it is optically inactive compound, it is achiral. So, polarimeter compulsory na? So answer is no. So based on the symmetry elements, we can determine whether a compound is optically active or not, that is chiral or achiral. So what will the criteria for optical activity? To exhibit optical activity, the molecule must be chiral. Then a chiral kavali ante em condition kavali. So it has a non-superimposable mirror image. Adhyaropitam kani pratibimvam undali. So pair has come from the word. The chirality word has come from tear, means that is hand, actually hand, that is handedness, left-handed, right-handed, like that. So you check whether the reflection is equals to object, then if the reflection is not equals to object, then it is non-superimposable. Let us look some objects. So hand, non-superimposable. Then this small chair. So object is superimposable on its mirror image. Let us look at this screw. So some more molecules. So chiral molecule has a non-superimposable mirror image, whereas an achiral molecule has a superimposable mirror image. So how to know whether a compound is chiral or not? Oka sammelanam chiral lekunte achiral ani cheppadaniki etta. So molecular symmetry is useful in determining whether a compound is chiral or not. So what is the necessary and sufficient condition for chirality? So the presence or absence of Sn will decide whether a compound is chiral or not. If Sn is present, that is improper rotational axis or rotational reflection axis. If that is present, the compound is symmetric and it is achiral, means optically inactive. If Sn is absent, it is non-symmetric. Compound is chiral, that means optically active. So therefore, absence of Sn is the necessary and sufficient condition for chirality. ఒక సమ్మేళనం chiral కావాలి అంటే Sn ఉండకూడదు. అయితే మనం ఇంతకుముందు వీడియోలో చూసాం మనం Sn లో n ఆడ్ అయితే ఇట్ ఈస్ ఈక్వల్స్ టు మిర్రర్ ప్లేన్, దట్ ఈస్ ప్లేన్ ఆఫ్ సిమెట్రీ. ఈవెన్ అయితే సెంటర్ ఆఫ్ సిమెట్రీ. సో S1, S3, S5 etc. will be equals to the plane of symmetry, and Sn when n is even equals to center of symmetry. So therefore, instead of Sn, it is better to identify, which is easy to identify, whether sigma is present and Ci, that center of symmetry, is present. So therefore, now you can conclude that a molecule is chiral if plane of symmetry is absent and center of symmetry is absent. సౌష్ఠవ తలం ఉండకూడదు, సౌష్ఠవ కేంద్రం ఉండకూడదు. ఈ రెండు ఉండకుంటే ఆ సమ్మేళనం తప్పనిసరిగా కైరల్ అవుతుంది. Look at some objects. So it has plane of symmetry. It doesn't have plane of symmetry. So plane of symmetry means an imaginary plane that will bisect the molecule or an object into equal halves. So an equal halves of the equal halves of the equal part. So here you have, here there is no plane of symmetry, here there is no plane of symmetry. Now come to center of symmetry. So start from here, go to the opposite plane, you are meeting an equivalent group, so therefore it has center of symmetry. Look at here, it has center of symmetry. So this molecule is also having center of symmetry. So this is optically inactive, this is also optically inactive. Tartaric acid, mesotartaric acid in staggered conformation. Look at here. So look at here, it has a plane of symmetry. So therefore it is achiral. So there is no plane of symmetry and also no center of symmetry. Therefore it is chiral. So if a carbon is attached to 4 different groups, it is called as asymmetric carbon or chiral carbon. So any atom, not only carbon, any atom that is attached to 4 different groups, it is called an asymmetric center or chiral center. Now, is it necessary to have a chiral center in a molecule to be chiral? So molecule chiral కావాలంటే దాంట్లో chiral center తప్పనిసరి ఉండాలా? ఉండొచ్చు, ఉండకపోవచ్చు. Not necessary. So chiral molecule may or may not contain a chiral center. కాబట్టి chiral center ఉంటే డెఫినెట్లీ ఉంటే డిసిమిలర్ ఉంటే మనం చూద్దాం మనం జస్ట్ నౌ look at. So molecule that is having chiral center. So 4 different groups it has. So some more examples. So this is the cholesterol, a biomolecule which has 8 chiral centers, 8 chiral carbons. So let us check. Why? Because there are 2 similar groups. So therefore it will have a plane of symmetry. So therefore it is achiral. Chiral. This is again having 2 similar groups. So 4 dissimilar groups. So chiral, chiral, chiral. So now we are in a position to define enantiomers. Enantiomers means a pair of stereoisomers that are non-superimposable mirror images of each other. So that is, if you can look at here, this wedge has become dotted, or it could be other way also. If you can put the plane, mirror plane here, left will become right. So therefore this is non-superimposable mirror image of this object. So therefore this is chiral. This pair we call it as enantiomers. So the Cl is towards this observer but away from this observer. So we can, the same fellow looks different way, the molecule he will look the molecule different way, he will look the molecule different way. The Cl appears as a wedge to this person, this observer, and the same Cl looks like attached to a dashed line to this observer. So, in fact, in both cases, so one will become the enantiomer to the other. So then, some more examples. Pair of enantiomers. So usually, one interchange will result in its counterpart, it's an enantiomer counterpart. Look at here. So this is the interchange. So at each carbon, so configuration will change. Wedge will become dash and dash will become wedge, or left will become right, right will become left. Here, look at here. So plane, mirror plane is put here, that is reflected over with this plane. So left has become right. So here it is mirror plane is put, just now we have shown like that. So therefore this way, sideways. So therefore what happens? Wedge will become dash, dash will become wedge. So one interchange will give you the enantiomers. So they will have similar physical properties, but they rotate the plane of polarized light in opposite directions, and similar chemical properties, but they will have a different behavior with a chiral reagent. So what is a meso compound? Some compounds are having chiral centers, but still they will be optically inactive. Such compounds are called as meso compounds, that is optically inactive compound in spite of having asymmetric carbons. This is due to the presence of either plane of symmetry or center of symmetry. Look at here, plane of symmetry. So we have plane of symmetry. So these compounds are meso compounds. So then what are diastereomers? Non-superimposable, non-mirror images. Thumb rule ఏంటి అంటే కొంత పార్ట్ సిమిలర్గా ఉంటుంది, కొంత పార్ట్ ఏమో మిర్రర్ ఇమేజ్గా ఉంటుంది. So that is how you will be identifying the diastereomers. Look at here, this bottom part, the R configuration at this chiral center is same, here it is opposite. Such type of compounds we call them as diastereomers. అధ్యారూపితం కాదు, అట్లాగే బింబ ప్రతిబింబాలు కూడా కావు. They are non-superimposable and also non-mirror images. So some more examples. Look at here. So diastereomers. So okay. Yeah. So then even cis-trans isomers or EZ isomers are also called diastereomers. So just now we have discussed that the presence of chiral center is not necessary for the molecule to be chiral. So therefore let us look at which type of molecules are chiral even though they do not contain chiral centers. Chiral center లేకున్నా కూడా chirality ఉంటుంది. Usually aldenes, spirants, biphenyls. Look at here. So aldenes kanka at one terminal similar groups unte, it will have a plane of symmetry. They are optically inactive or chiral. అలా కాకుండా different groups unte, they are chiral. So aldenes are chiral if two groups attached to each terminal carbon are not same. If they are same like this, they are achiral. If they are not same, they are chiral. Similarly, spirants and biphenyls, ortho prime positions. Usually, so simple biphenyls are optically inactive because there is a free rotation around the cis bond. But when you introduce some bulky groups in ortho and ortho prime positions, the free rotation is restricted and the two groups will become mutually perpendicular to each other. So therefore, with a suitable substituents, they will be chiral. So such a type of isomerism is called as atrope isomerism. These are some more examples. So let us look at the number of optical isomers. If all the chiral centers are dissimilar, that is non-similar, so there will not be any mesoisomers. There will be only active isomers, which is equals to 2 power n. So look at this. This is an example of aldohexose. There are 4 chiral centers. 2 power 4 means 16 isomers. One of them is glucose. So here you have 2 chiral centers. So 2 power 2 means 4 isomers. If chiral centers are similar, again 2 cases, even and they could be odd. If they are even, so active isomers is equals to 2 power n minus 1, mesoisomers is equals to 2 power n by 2 minus 1. Let's take, for example, if there are 2 chiral centers, similar chiral centers, active is equals to, using this formula, it comes out to be 2, meso comes out to be 1. So that's how. So this is, where is it? This is meso. These 2 are active. So these 2 are enantiomers. That is a pair of enantiomer. 1 meso compound, total 3. 2 plus 1, 3. Suppose if n is odd, that is similar odd asymmetric carbons. So this is the formula, 2 power n minus 1 minus 2 power n minus 1 by 2 active isomers. Meso will be equals to this one. Total will be equals to A plus M. Let's look at, if there are 3 chiral centers, so it comes out to be, there is number of active isomers will be 2. Similarly, number of mesoisomers will be equals to 2 when you substitute 3 in these equations. Total isomers will be 4. So look at here. This is only one and only one meso compounds. You can take the configuration that we'll discuss later, or by simply rotating in plane, that is in plane rotation is allowed. We have seen while discussing the symmetry. So these are same, one meso, second meso. So then we have another pair of enantiomers. So therefore, 2 enantiomers, 2 meso, total 4 isomers we have. So this, okay, then total 4 stereoisomers. So racemic mixture means that is equimolar mixture of enantiomers. That is 50-50 mixture of enantiomers. Let's look at here. So look at here. Achiral stereoisomers are possible for. So not possible for this one. Again, not possible for this one. It will have a plane of symmetry in one of the stereoisomers. In one of the stereoisomer, it will have a plane of symmetry. So therefore, C and D. So look at the diastereomers, for example. Thumb rule manam emankunnamandi, non-superimposable, non-mirror image. Okay, but thumb rule is, so some part will be equal, remaining part will be mirror image. So kabatti cis strands are EZ lo తీసుకున్నా కూడా మనకి they are diastereomers. Look at here. ఇక్కడ మాత్రం కాన్ఫిగరేషన్ డిఫరెంట్ ఉంది, మిగతా సేమ్. ఇక్కడ కూడా చూడండి cis strands. So therefore A, B and D. Number of stereoisomers ఇప్పుడే చేసాం మనం, 3 రావాలి. ఎస్. సో ఇది ఇట్లాంటిది ఏంటంటే కాన్ఫిగరేషన్తో ఈజీగా చేయొచ్చు, విల్ డిస్కస్ లేటర్, బట్ స్టిల్ యూ కెన్ డూ ది అదర్ వే. సో దిస్ ఈస్ గివెన్, దీస్ ఆర్ ది కాంపౌండ్స్ గివెన్. సో వాట్ ఐ డూ ఈస్ ఐ మేక్ అన్ ఇన్ ప్లేన్ రొటేషన్. దీన్ని ఇట్లా రొటేట్ చేస్తాను. COH కిందకి వస్తుంది, CH2OH పైనకి వస్తుంది, NH2 ఇక్కడ వస్తుంది, Br ఇక్కడికి వస్తుంది, రైట్. So now look at here, this 5 is same as 1. Now look at third one. Third one is the mirror image of 5. So 5 is same as 1. So therefore 1 and 3 must also be enantiomers. This, so 1 and 3. So because 5 and 3 forms a pair of enantiomers, so naturally 1 and 3 must be enantiomers. Yes, the answer is 1 and 3. So this is something about the concept of chirality. So how you will be identifying the compounds which are chiral or not. So in our next discussion, we will be discussing about the Harris nomenclature. Thank you very much.